All right, guys, April 22nd today. This is a two-section day, so this is the second day of it. So far, we've spent time solving right triangles specifically, okay, and angles of depression and elevation and that kind of thing. What do we do if the triangle is not a right triangle? And that's what we're going to be focusing on today. We're going to have a couple of rules, the law of sines and law of cosines, to help us solve them, okay? This isn't the specific definition. I will give you the actual law in a second, but I want you to recognize that for the law of sines, it works really well if you're given an angle side or an angle side angle. And the law of cosines works really well if you're given side 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 or side angle side. We'll revisit this at the end one more time, but just a reminder that that's when you should use them. Okay, so the law of sines is pretty straightforward. The sine of an angle over the side opposite, so sine of A over A, is equal to the sine of B over B and the sine of C over C. So it's just ratios again. So back in chapter 7, we spent a lot of time solving ratios. That's all we're going to be doing here, you guys. So if you're given a couple of angles, this works out quite well. So let's do one together. I'm asked to find P. So the sine of an angle, sine of 29 over 8, is equal to the sine of 17 over P. P is the unknown. I've just got a proportion that I can use, okay? Like so, and then we cross multiply and eventually divide, right? So 8 times the sine of 17 equals P times the sine of 29. I need to divide by the sine of 29 to get P by itself. Make sure you're in degree mode, literally type it into the calculator like that. P is about 4.8. Okay? All right, pause the video, give this one a shot. All right, let's see how we did. Focus on the angles given. So the sine of 47 over the side opposite, 16, is equal to the sine of 23 over the side opposite, which is little c. And that's what we were asked to find. Here's little c. So I grab my calculator, I type in 16 sine of 23, and then I divide by the sine of 47, and I get 8.5. There you go. Simple proportion, you guys. These ones shouldn't be too hard. Okay, so let's look at it if you're given angle side angle. Okay, so I'm going to go the sine of 50 over x equals, what's c? How are we going to do that? Well, think back a few chapters. We know that all three angles have to add up to 180. So I add these two up and I get 107. This must be 73 degrees then. So then I could say the sine of 73 over 6 equals the sine of 50 over x. And we're just solving that same type of proportion we just got done with, okay? So get x by itself. Again, 4.8, same thing we got for the previous example, okay? How about this one? This one's even easier because I don't need to find g, so this is pretty similar to what I did before. So the sine of 55 over 12 equals the sine of 43 over x. Okay? And that's what I'm asked to find is x, so I'm going to type into my calculator 12 sine of 43 divided by the sine of 55. I get 9.99 or about 10. There you go. So law of sines, setting up proportions. Hopefully after a couple examples you're pretty good at solving these. And again, this works for triangles that are right triangles, okay? Law of cosines, a little trickier. They write 3 different versions of it because it really depends upon which angle you're given or which angle you're looking for. So if I'm going to focus on little a here, a squared equals, and then I focus on the other two sides, b squared plus c squared minus 2 times b times c times the cosine, and that angle is always opposite that side, okay? So if I have little b on the left side, then cosine b is on the right side. If little c is on the left side, then cosine c is on the right side. So somewhere in your notes you need to write this down. Solving it isn't going to be terribly hard. It's a lot of calculator work again, but you have to have it down so you put the numbers in the right spot, okay? So let's take a look. I'm given side angle side, so law of cosines works pretty well. I'm gonna write out here on this screen so you can see it, what we would do, and then we'll see it solved on the next screen, okay? So I'm missing the x, and the x is opposite the known angle, so that's gonna be on the left side. I'm gonna write x squared equals 11 squared plus 25 squared minus 2 times 11 times 25 times the cosine of the angle opposite that. So that's what the law of cosines is going to work and then look like. What you guys are going to do as you work through this is memorize the pattern ultimately. Once you do 3 or 4 of these, you won't have to look back at it anymore. I think it's important to have it in your notes to reference for a test, but I think you'll get it down, okay? Now, honestly, solving this, you guys, and we'll see this on the next screen, the whole right side of the equal sign is just numbers. You can type all of that into the calculator, okay? So here we go. This is what we got. Type all of that into the calculator, you get a number. X squared equals whatever that is. And then you got to take the square root of it to get x by itself. So x is about 18.9, okay? All right, pause the video, give this one a shot. I'll set it up for you guys and then I'll put it in the calculator and show you how to do it. So the r that I'm missing is opposite the angle, so the little r is by itself here. R squared is going to equal 15 squared plus 32 squared minus 2 times 15 times 32 times the cosine of the angle opposite that. So in this case, 40. Okay? Again, you're going to notice that the whole right side of the equal sign here is just numbers. So I'm going to type into my calculator 15 squared plus 32 squared minus 2 times 15 times 32 times the cosine of 40. And I get like 513 or something like that. But that's what r squared is going to equal. I got 513.6, let's say. Well, to get r by itself, I need to take the square root of that. Now I get about 22.7, which is C. Okay? So once you have it set up, the algebra, it's a lot of calculator work. Okay? All right, let's look at an example where I'm trying to find an angle. This is going to be a little bit tougher on the calculator, but we'll still get it figured out. I'm trying to find L. So opposite the L is the 24. That's what's going to go on the left side then, is what's opposite the angle I'm looking for. So 24 squared is going to equal 5 squared plus 27 squared minus 2 times 5 times 27 times the cosine of that angle opposite the 24, which in this case is L. So I've got some algebra to do this time. I've got to isolate that L, okay? And that's what I'm going to take you through in the next screen here. But this is how I would set it up, okay? So think about how we're going to do this. We can go ahead and square some of that stuff, right? 24 squared, 27 squared plus 5 squared is that 754. 2 times 5 times 27 is the 270. Now I need to isolate this, right? I got to subtract the 754 from both sides. I have to divide by negative 270. Okay, so this is a number, whatever that is. And if I want to isolate the L, I need to get rid of cosine, you guys. So I need to take inverse cosine of whatever I have on the left side. Okay, and that's going to give me my angle approximately, about 48.8 degrees. So this requires a few more steps if you're looking for the angle, but it's still pretty doable. Okay? All right. Pause the video and give it a shot here. All right, so I'm looking for angle P. Opposite the P is the 2.9, so I'm going to type in 2.9 squared equals 1.3 squared plus 3.1 squared minus 2 times 1.3 times 3.1 times the cosine of P here. Okay? All right. How are we going to get this by itself? So I'm going to type into my calculator 2.9 squared. I'm going to subtract 1.3 squared. And I'm going to subtract 3.1 squared. Okay? And so in essence, I've eliminated those. Okay? I'm at like negative 2.89 though. Well, I still have all of this stuff over here. This stuff's really just being multiplied by cosine P. So I'm going to divide by parenthesis negative 2 times 1.3 times 3.1. Okay? And now I've got 0.358. And so I've eliminated all of this stuff too. So now I've got 0.358 equals the cosine of p. And if I want to get p by itself, I have to undo the cosine. So I'm going to go inverse cosine of that 0.358 that I got. I get about 68.98, so very close to 69 degrees here, looks like. Okay. All right, now we're just going to put this into action. You know, from the diagram of the plane shown, determine the approximate width of each wing. Okay, so we're looking for x right there. Now there's two ways of doing this. I do have side angle sides, so I could use the law of cosines here, but because this is an isosceles triangle, I know that these two angles are the same. So 180 minus 50 is 130, and these two are the same, so half of 130 is 65. Well, now that I know both of those angles, I could use the law of sines. You know, I could say that the sine of 50 over x equals the sine of 65 over 20, which is my guess as to how they're going to solve this, okay? And then cross multiply and divide like we have before, and you should have no issues coming up with about 16.9 meters there. All right, pause it, give this one a shot. So it says, the rear side window of a station wagon has the shape shown in the figure. Find the perimeter of the window if the length of DB is 31. That's that diagonal, okay? So in order to find the perimeter of the window, I've got 15.76 and I've got that 16 over there. I'm going to need DC and I'm going to need AB. Okay? And so, what kind of information do I have up here? So they give me that as 66. So in this bottom triangle here, I've got a side and those aren't quite the same. So I've got a little bit of work to do there. We got to think through this one just a little bit. It's not a parallelogram, because if it was, these two would be the same, so I can't assume the alternate interior angles are congruent there. Let's look at the top triangle there. I've got a side angle side situation, because I've got this, the 66, and then this, so I could find AB. And so I could say that AB squared is equal to 15.75 squared plus 31 squared minus 2 times 15.75 times 31 times the cosine of that 66 degrees. Okay? So the whole right side of that is a number, so 15.75 squared plus 31 squared minus 2 times 15.75 times 31 times the cosine of 66 degrees. I get 1606, but again, that's what AB squared is, so I'm going to take the square root of that answer, and I get about 40, okay? So now I know that that side is 40, okay? And so then I gotta, so what do we have so far? 40, 56, 66, 70, 71.75, and so yeah, I haven't really narrowed anything down quite yet. In that other triangle, I've got some work to do. I have to find a missing angle, and then I can use law of sines. So, because I've got a side-side angle situation over here. So, let's go. Let's call this x right here, this angle right there. So the sine of x over that 16 is equal to the sine of 68 over 31. Okay? So this one's a little trickier. I'm going to type into my calculator 16 times the sine of 68. And I'm going to divide it by 31. Okay? That's what the sine of x is. All right, so I have to type in inverse sine if I want to eliminate that. and then put in that decimal that I got, so that's about 28.6 degree angle here. Okay, so that X right there is 28.6. Now that I know that, I can say that the sine of 28.6 over 16 is equal to, okay, let's subtract from 180 here. So I got 180 minus 28.6 minus the 68 that I've been given. So this angle is right up here, is that 83.4. So now I can go the sine of 83.4 over x. Okay, that's going to be that side at the bottom there, that DC. Okay, so 16 sine of 83.4 divided by the sine of 28.6. Okay, I get about 33 for x over here. 33.2. So my perimeter, 15.75 plus 40 plus 16 plus the 33.2 that we just got. Find the perimeter of the window if the length is dB. Honestly, they didn't get it right. I got 104.95, so if you work all that out, you should get 104.95. Somehow the book screwed up on this one. Sorry about that. All right, solve the triangle. We had to do some of these back in a couple sections ago, section 8.4. So solving it means I need to find unknown lengths. So I've got a side, 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 so I'm going to use the law of cosines to help me get started here. And so they choose to find p first, okay? So they're going to say p squared, which is 8 in this case, is equal to r squared plus q squared, etc. So 8 squared equals 9 squared plus 7 squared, etc. You guys remember the law of cosines, we can work it out. So I'm going to have to go ahead and square all of that stuff. I'm going to subtract 130. I'm going to divide by negative 126, and then I have to type inverse cosine to get that. Okay, so I get 58 degrees. So that's one of the angles. Now that I have one angle, I can use the law of sines to find the others, okay? And that's the idea now. Now that I've got that 58, I can go in and find a missing angle. And now that I have two angles, of 58 and 48, I can subtract from 180 to get the third one, okay? So that's not so bad. All right, give this a sec, and let's see what you get. We'll work it out together. All right, so I'm going to start by trying to find r, okay? So I'm going to go 14 squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of r, okay? And so in our calculators, let's go 14 squared minus 9 squared minus 12 squared, eliminating these guys here, okay? And then I'm going to divide by negative 2 times 9 times 12, eliminating that. So I have cosine r by itself. So I'm going to type in inverse cosine of what I got. And I get 82.3 degrees. Okay? And I'm going to use the law of sines now to find one more angle, and then I can subtract. So 82.3 for r. That one seems okay. That one's not okay. That one. Okay, so we've narrowed it down a little bit. Okay, so let's say the sine of 82.3 over 14 is equal to the sine of s over 12. Okay, so let's see what we get there. So 12 times the sine of 82.3 divided by 14. Again, that's going to be what sine s equals, so I have to type in inverse sine of my answer to get s by itself. And I get 58.1 for s here. Okay, so 58, that's possible. I don't think it's this one. Okay, and then I should double check. So if I take 180 and I subtract the 82.3 and I subtract the 58.1, I'm left with about 39.7 down here. They're saying about 40, so that seems accurate. Okay, that's how I would solve that. All right, so this last page is just a reminder as to how to solve it. If you have a right triangle, again, this is how you know you've got that kind of a situation. Then you can use sine, cosine, or tangent just with those ratios like we did in section 4. But if you don't have a right triangle, if you have angle, angle, side, or angle, side, angle, the law of sines works pretty well. If you're given side, angle, side, or side, 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 then the law of cosines works pretty well. And there's your assignments, you guys. So the first one today was pretty small, and so this one's not a lot bigger. Just practice solving triangles. Good luck.